This is an ollie. An ollie is a fundamental skateboarding trick, putting enough force on the board for it to bounce off the ground and lift into the air, while lifting your feet at the same time to be caught by your feet a higher distance in the air than when you started. I wanted to take today to analyze the physics involved in making an ollie happen. Specifically, I wanted to talk about the force required to lift a board, let's say a distance of half a meter. Now, what we're interested in finding is how much force is required to move the board a certain distance. We can find that using the formula for work, which is force times distance. Work is a measurement of how much force is required to move an object a certain distance. If we're looking for the force then to move the object half a meter, we need to know how much work is done to get the board from the ground to half a meter. We can actually use a concept called the conservation of energy to do this. The board has a certain amount of energy when it's leaving the ground. This would be kinetic energy, or energy that moves the board in a direction. The board with enough kinetic energy to reach a certain height would also have that same amount of energy in the form of potential energy when it's at that height. In this case, it's potential energy relating to gravity. Since the board would be half a meter off the ground, the board has enough energy due to the acceleration of gravity pulling it down to then move that same distance back down to Earth. So we can calculate the potential energy of the board when it's at its max height, or in this case half a meter. Let's just say the board is about 1.5 kilograms, times the acceleration of gravity, which is always 9.8 meters per second squared, times the height, which in this case is half a meter. Then doing the multiplication, we can find that the board has 22.05 joules of potential energy when it's at half a meter in height, at a mass of 1.5 kilograms. We then know that the board must have had that same energy when it left the ground, because otherwise it wouldn't have had enough energy to get there. The kinetic energy of the board when it left the ground was also 22.05 joules. Now, there's a relationship between kinetic energy and work that states that the change in kinetic energy is equal to work. In this case, we're just looking at the kinetic energy on the ground, so there's actually no change. So we could say that the work required is 22.05 joules. Doing some algebra, we can rearrange the work equation to solve for force, which would result in 44.1 newtons of force being applied to the board upwards until it reaches a height of half a meter. As far as physics is concerned, all you would need to do is apply a force of 44.1 newtons to the board, which is about the same as pushing a semi-full shopping cart when it hits the ground in order to make the board ollie half a meter.